Kia ora Year 9. Thanks for watching this video that's going over the JAF practice questions. In this video, I'm going to start with the Unistructural questions. I'm going to aim to get through about the first 9 or 10 questions. As usual, make sure you've got a pen and paper with you to do the questions with me again as you go. And remember, if you've got questions after you're watching, either email me or leave me a comment. And remember that Education Perfect is really brilliant on all of this, so you can figure out where you've got a gap in your understanding and go and redo the EP that helps with that topic. So let's start by looking at what the formulae are that you're going to get given. You'll probably know most of these, but it's really nice to have them there in case you forget. So the first couple, the two easiest ones in here, I reckon, are the area of a rectangle and the area of the parallelogram. And they're both the same thing, base times the height. The close relative of the rectangle is the area of a triangle, right? And we can see that because if we chop a rectangle in half, we get a triangle. And the area of a triangle formula is half the base times the height. The circle formulae are over here. The circumference of the circle measures the distance around the outside, and that's 2 times pi times the radius. Remember, the radius goes from the center to the edge of the circle. And we saw that you can write this another way. You can write this as pi times the diameter, right? Pi times d, and the diameter goes from one side of the circle to the other, going through the center. Then we've got a couple of volume ones for when we're working in 3 dimensions. The cylinder formula comes from the area of a circle times the height, and the volume of a prism, is this one here. Now this looks hard, but it's actually pretty easy when you see how it goes. We look at the cross-sectional area times the depth. So let me draw a bad picture of a prism. We're going to use all of these when I get into the questions, of course, but I'll just start with this now. So suppose that I've got this. Now, you're going to look at this and go, well, that's a cuboid, miss. I can find the area of that by length times width times height. But it's also a prism, and it gives us a good illustration of how this prism formula works. So the cross-sectional area means whatever thing is the same the whole way through. So we find that area, which we'd get by length times width or base times height, and then we just times it by how far back it goes, by how deep it is. So that's where the prism formula comes from. And when I'm thinking about the volume of a prism, I always think about a box of Toblerone chocolate. And if I remember that one, then I kind of remember where the formula comes from. Okay, that's enough talking from me. Let's get into the questions. So question 1 and question 2, which units are used for measuring length? Right, well, it's not litres because that measures liquids, liquid volume. It's not cubic meters because that measures how much space something takes up. It's not square meters because that measures area. It's just simple meters. Okay, now the next one is one looking at time. Now we haven't spent much time on this in class, so let's have a look now. So on a Saturday, Roger studied from 10:45 a.m. to 12:20 p.m. Most of you will probably do this in your head, but I quite like doing a number line for this. So let's start here at 10:45, and we're looking at going to 12:20. So my brain works in jumps of 1 hour, so 1 hour, 2 hours, gets me to 12:45. Right, so then I've gone too far. So I want to go back to 12:20. So it's 2 hours minus 25 minutes. That's one way to think about it. So how long did he practice? Well, there are 60 minutes in an hour, so this is 1 hour and 35 minutes. Or the other way I could do it using the number line is this. Let's get rid of all of this. And we'll get rid of that bit there. I could go up in blocks of an hour, right? So I'm at 10:45, starting here. I go to 11:45, and I see that I just want to go to 12:20. So we can hop to the next hour, which is here at 12. Right, so I'm up to 1 hour, 15. to get to here, and then I want to get another 20. So that gets me 1 hour, 35 minutes. All right, so either of those methods is fine, but the number line really helps when we're doing more complicated ones like that. So he practiced for 1 hour, 35 minutes. As usual, make sure you give your units. Okay, question 3 and 4. Well, I'm not going to do question 3 because stupidly when I copied over the question from the worksheet, I stretched the thing. But if you measure that properly, it works out to be 10 centimetres. The key thing to remember when you're using your ruler is make sure that your 0 mark is on the start of the thing that you're measuring. Number 4, calculate the perimeter of these figures not drawn to scale. In other words, don't try to measure them. So the perimeter is the length of the fence around the outside. So P is equal to 10 plus 4 plus 2 plus 8 plus 4 plus 4. And when you add that up, you get 32 centimetres. Always give your units. The next one is asking for the perimeter of this figure here. Now it's a circle, so we usually don't call it the perimeter. We usually call it the circumference. That's okay. So the formula we want here is on my formula sheet, and that's C is equal to 2 pi r. And in this question, r is equal to 8 centimetres. So we substitute in r is 8, and we get 2 times pi times 8, and that gives me 16 times pi, and that comes out of my calculator as 50.265 blah blah blah, but I want to round it intelligently. So I'm going to round to 1 decimal place. I want to have 1 decimal place here, so I look at the next number. It's a 6, which is bigger than 5, so I go up. So we get 50.3 centimetres. Okay, question 5. Calculate the area of these shapes. So this is using the formulae that we had right at the start. This one is a rectangle, this is a parallelogram, this is a triangle, and then this one's the area of a circle. Okay, so going back to here, you can see the formulae that we need. Okay, area of a rectangle, area of a parallelogram, triangle, and circle. Whoops, wrong pen. Sorry guys, just let me fix that up. Okay, so 5a, the area is equal to the base times the height. The base is 10, the height is 5. All right, so the base is this one across here, the height's 5. Doesn't matter if you turn it around because multiplication is commutative, the order doesn't matter. So that's 50, but we need the units, and the units are centimetres squared because I'm measuring the area, right? And you can remember that by thinking about dividing this up and getting lots of little squares. B is a parallelogram. Now the thing we've got to watch for when we do parallelograms is which ones of these numbers are the ones that help me with my calculation. So 7 is the base, but is 4 or 5 the right number for the height? Well, 5 is just put in here to make you remember how it works. We don't want to use that 5. The height is the height that forms a perpendicular line to the base. In other words, a line at 90 degrees. So for this one, the base times the height is 7 times 4, which is 28 meters squared. Next, we've got our triangle. The base is 3 and the height is 8. And we can see in here this rectangle, which is signaling to me that this is the right number to use for the height. Okay, so for C, we've got area is equal to half times the base times the height, which is a half times 3 times 8, and that gives me 12, and I think it's centimetres squared. Now the last one is my circle. The radius is 8, so the area is going to be pi r squared. Area of a circle is pi times the radius squared, which is pi times 8 squared. Now remember 8 squared is 8 times 8, so 64 pi, and that gives me 200 and something, 201.06 blah 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 blah. Rounding that, I get 201.1 centimetres squared. All right, let's see how we go with number 6. So number 6 says which of these is the smallest length? So this is an exercise where we want to see that you're comfortable with converting units. And I'm going to convert all of them into meters. Right? So 5 meters and 23 centimeters, I can write like this, 5.23 meters. So how did I do that? Well, for some of you, you'll be good at going from centimeters to meters in your head, but for lots of you, you'll still be having to think hard about what we do to do that. So 23 centimeters is equal to 23 divided by 100 meters. And if you work that out, you get 0.23 meters. So that means for A, I've got 5 meters plus 0.23 meters. And that gives me 5.23 meters. B is already in that format, so that's good. This one here, 553 meters. Well, we can divide that by 100 to get meters, right? So C is equal to 5.53 meters. So we've got one left to do where we have to convert this into meters. We've got 5 meters and 2 centimeters and 3 millimeters. So let's convert all of those bits into meters. Well, 2 centimeters is equal to 2 divided by 100 meters, which is 0.02 meters. And 3 millimeters can be converted into meters as well. So 3 millimeters is 3 divided by 1,000 meters, right? Milli means thousandth. So that's 0.003 meters. So when we add all of that up, we get 5 plus 0.02 plus 0.003 meters, which gives me 5.023 meters. So now we can answer the question, which is which one is the smallest length? And it turns out that it's D, right? So D is the smallest. Right, and I can see that easily because once I've got them all in the same unit, I just use my understanding of decimal place value. Right, so I'm just going to spend a tiny bit more time looking at that so that we can check that we really do understand how place value works. So A is 5.23, B is 5.32, C is 5.53, and D is 5.023. So all of them have got the same units, right? So they've all got 5 here, so we can't distinguish them yet. But now we have to look at the next column over, which is the tenths column. This has got 2 tenths, this has got 3 tenths, this has got 5 tenths, but this one's got no tenths. So because there's a clear winner for the smallest here, that this one's got no tenths, it doesn't matter about the stuff after it, right? It doesn't have any impact on the ordering of them. So that's how we know, as soon as we get that second place worked out, that this one is the smallest number. Right, one last question, and then I'm going to stop, and I'll do another video soon. I'm not sure if anyone's still watching, because 13 minutes is a lot of JAF practice to watch in one go. So let me know if you are. Right, so 2.3 meters plus 400 millimeters. Well, 400 millimeters to convert into meters has to be divided by 1,000. And that gives me 0.4 meters. So when I add those two together, I get 2.3 plus 0.4 is equal to 2.7 meters. Now, these conversion skills are really important, and they are really, really good in Education Perfect. So if you're feeling a little bit wobbly on questions like this one, do make sure you put in the time to do, I think it's called level 4 units of measurement. Okay, and if you're in my class, you've had that work set for ages, and I think almost all of you have finished that off to a really good level. But just in case, go back and have another look if you're not confident on this. Thanks for watching. I'll be back with questions 8 to 15 quite soon.